Cisco Certified Network Associate Day 3 Late Night. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. We stopped doing subnetting in our last video. We will continue from there for this video, and then we will introduce another concept called Supernetting. Without wasting much time, let's get straight into today's video. Before we continue, I need to show you this. I know most of you would be asking, why is Imran showing all these irrelevant stuff? Pictures of things that is not even connected to networking. Well, maybe that's my way of teaching, and I'm sure that's helping a lot of people. I try to take your everyday objects and try to link it to the concept that I'm teaching. So let's talk about the digital clock. Now everybody, I'm sure everybody knows how to read a digital clock. Now according to this picture, it is 13 hours 45 minutes 27 seconds, right? So the next second after this is 13 hours 45 minutes 28 seconds. So if you keep adding 1 second to the time, it would reach a point where it goes to 13 hours 45 minutes 59 seconds. You add 1 more second to that, it becomes 13 hours 46 minutes and 00 seconds. Then the process continues. You keep adding seconds, it goes to 45 59 seconds, then it becomes 46 00 seconds. So every time it reaches 59, it resets itself to 0 and adds 1 to the previous place. Now similarly, a point would come where it becomes 13 hours 59 minutes 59 seconds. You add 1 more second there, it becomes 14:00:00. 1 second before 14:00:00 is 13:59:59. Well, that's how a digital clock works, and we all know that. So 1 second before 1400 hours is not 1300 hours, it is 1300 hours 59 minutes 59 seconds, right? Remember this concept because we would be using this in our IP addressing schemes. Right, let's start with class B subnetting. We'll take this IP address 172.16.100.225, and we know the default subnet mask is 255.255.0.0. let's try and break this into 2 subnets. From what we know already, we know that to break a network into 2, we borrow 1 bit, like what we see here. Let me take a pen. Alright, so we see that 1 bit is borrowed. Now from what we know already, 1 bit borrowal means you get 2 subnets, 2 to the power 1, which also means that you get 2 to the power 15. 15 is nothing but the number of zeros, so 2 to the power 15 minus 2 hosts, that is 32,766 valid hosts. How do we get the first network's network ID? We know this from our previous video. We remember, for a class B, 172.16 is class B, so this is the default subnet mask, and this is where the default division is, right? So the first network ID is going to be where you do 172.16 and make everything else that you see here in green, which is the host part, make everything as 0. So the first network ID is 172.16.0.0. How do we get the second network ID? The second network ID is got by adding the place value of the last one. So last one here is this. The place value is 128. Now this is the critical bit. In class C, we added that to the last octet. Why did we do that? Because that last one was part of this last octet. In this case, in this particular case, the last one is part of the 3rd octet. So we would be adding that 128 to the 3rd octet. So the first network ID is 172.16.0.0. the next network ID is 172.16.128.0. see, this last one was part of the 3rd octet, so we added that place value to the 3rd octet. Can we add one more? Can we have one more network? No, we can't, because if we add 128 again, it becomes 172.16.256.0, which is not right, because 256 is not a valid IP address. So also we know that by borrowing 1 bit, we're breaking it into only 2, so we can't have the third network ID. How do we get the broadcast ID? Broadcast ID is 1 minus the next network ID. So 1 minus 128.0 is 127.255. Remember the digital clock. 1400 hours minus 1 second is 1359.59. So 128.0 minus 1 is 127.255, which is our 255 is the largest number, right? And the broadcast ID of the last network, as we always know, is making everything as 255. Like the first network ID is 0.0, the last broadcast ID is 255. It's very, very simple, isn't it? Right, because of this borrowing, what happens to our subnet mask? Our subnet mask is 128.0, because this 1000000 is 128.0, and that is nothing but /17 because we borrowed 1 bit. It's very easy. I don't know why people think it's such a big deal. I don't think so. It is very simple. All you need to know is know the basics, and that's how easy it is. Okay, let's try another example. 172.16.100.225, the same IP address, but this time we're going to break it into 4 subnets. So from what we know already, to break a network into 4 subnets, we borrow 2 bits. This is the 2 borrowed bits. From the same formula, from what we know already, 2 bits is 2 to the power 2 is 4 subnets, and 2 to the power 14, which is nothing but the number of zeros, minus 2 is 16,382 valid hosts. How do we get the first network ID? Now this is something you should be doing it like that. It should be second nature for you. First network ID is 172.16.0.0. Exactly right. How do we get the next or subsequent network IDs? We know we need to add the place value of the last bit. Place value of the last bit is 64. Where is the last bit? It's on the 3rd octet. So we need to add 64 to the 3rd octet. So it's 172.16.0.0. Add 64, it becomes 64.0. Add another 64, it becomes 128.0. Add another 64, it becomes 192.0. Can we add another 64? No, because it becomes 256.0, which is not valid. That's one way of looking at it. And we know there are only 4 networks. 2 to the power 2 is 4, so we only have 4 networks. Fantastic. How do we get the broadcast ID? Now that's the question. Again, 1 minus the next network ID. So in the first case, it is 64.0, the next network ID. Minus 1 is 172.16.63.255. Remember the digital clock. Now you know a digital clock, how it works. That's exactly how this works. So 64.0 minus 1 is not 63.0. Remember, it is 63.255. The reason I'm stressing on this is the most common mistake students do. 64.0 minus 1, they do 63.0, which is wrong, and they lose a lot of marks. Don't do that. 64.0 minus 1 is 63.255. The broadcast ID for the second network is 127.255. Third is 191.255. Fourth is 255.255, because that's the last network, and like we know from what we know already, the last network's broadcast ID is going to make everything 255. When I say everything of the green section. So the first network ID is making everything as 0 of the host part, and the last broadcast ID is making 255 for the host part. That's very, very, very easy. Guys, this is very easy. You just have to get that mindset that this is going to be easy, and it really is easy. People just make it so complicated that they think it's a big deal. It is not a big deal. Right, to continue, this new subnet mask is 255.255.192.0, and since we borrowed 2 bits, it is /18. Fantastic. Let's get into class A. Again, it's the same concept. All that changes is here the host part is spanning 3 octets. In class C, the host part spanned only 1 octet. In class B, it spanned 2 octets. In class A, it spanned 3 octets. Now let's break this into two network. We know the drill. Borrow 1 bit. Where is the borrowed bit? The borrowed bit is still in the second octet. Consider another case where the borrowals, you had borrowed, let's say 8 or 9 bits. If you borrow 9 bits, what happens? It goes here. Then what you would be working is, you would be working on the third octet, right? We will work on an example a little later in this video, but for now we are working on the second octet. The place value of the second octet is 128. Yeah, so like we already know, 1 bit borrowing gives us 2 subnets, and the valid host is derived with the number of zeros. So 2 to the power 23 minus 2 is 8,388,606 hosts. That's a big number. In your practical life, you will not see such large networks or such large subnets with which has 8 million hosts. That's not practical. We would be breaking it down to smaller subnets. Fine, let's get into this question. So what is the network ID of the first network? We know this very well by now. So the first network is making everything as 0, so it is 10.0.0.0. How do we get the next network ID? We add the place value of the last bit. So the last one is 128 and it's in the second octet, so we add 128 to the second octet to get the network ID. How do we get the broadcast ID? Now this is exactly why I asked you to think and compare IP addresses to the digital clock. 128 minus 1, what is it? You guys tell me. Yes, it is 127.255.255. Fantastic. And the last broadcast ID, as we always know, it is 255.255.255. Everything is 255. Fantastic, guys. This is brilliant. I mean, it is so easy. I think this should be introduced in class 1. all right. I know it's not that easy, but I mean, I think it is fairly easy. Because of the changes that happened, because of this new borrowing, the subnet mask becomes 255.128.0.0, and of course, because one bit borrowed, the /8 becomes /9. Right? Fantastic. Let's take another example. All right, this time you guys are going to do it. I'm just going to run this animation. So, breaking a network into 4, what do? Yes, borrow 2 bits. Fantastic. You guys are learning. You guys are very fast. 2-bit borrowing gives us 4 networks. Fantastic. And that has 4,194,302 valid hosts. What is the network ID of the first network? We all know this. Make everything into 0. Fantastic. So it is going to be 10.0.0.0. Fantastic. How do we get the next network ID or the subsequent network IDs? We add the place value of the last bit. In this case, it is 64 and it is in the second octet. So we add 64 to the second octet. So the network ID of network 2 is 10.64.0.0. Then it is 10.128.0.0. Then it is 10.192.0.0. How do we get the broadcast ID? We did this so many times. By now you guys should be doing it without even thinking about it. So it is 10.63.255.255. broadcast ID 2 is 10.127.255.255. broadcast ID 3 is 10.191.255.255. broadcast ID 4, which is the last broadcast ID, is nothing but 10.255.255.255. because of the changes that happened, the new subnet mask is 255.192.0.0, and because of the change, it is /10 now. Guys, this is absolutely kindergarten stuff. Really, kindergarten stuff. Well, I think going through the last video and this video, I'm sure you guys can do this just like your alphabets. Fantastic. Let's get into this magic table. Now this magic table, if you remember, subnetting will be even more easier. There's nothing to remember, it's very straightforward. The place value is what we always learned. You start with 1, 2, 4, 8, 16, 32, 64, 128. It's nothing but doubling. And the mask value, so when we borrow 1 bit, the place value is 128, which also makes this mask value for that particular octet as 128. So that is nothing but the same number, 128. How do we get the subsequent numbers? So 128 plus 64 will give you 192. 192 plus 32 will give you 1224, plus 16 will give you 240, plus 16 will give you 248, plus 16 will give you 252, plus 2 will give you 254, and then 255. So in your subnet mask, these are the 8 values that's valid. So if you give you a subnet mask of 255.127.0.0, that's not valid subnet mask. Valid subnet mask should be within these 8 numbers. So if your subnet mask is not within any of these 8 numbers, that means that subnet mask is invalid. Remember, that's why I ask you to by heart this table. I mean, at least these 8 numbers you need to know. These are standard numbers, either 128, 192, 224, 240, 248, 252, 254 or 255. Your subnet mask, I'm reiterating this again, your subnet mask has to be one of these numbers. You cannot have any other number in your subnet mask. Simple as that. Fantastic. Let's get into requirements. This is going to be real exam type question. So they give you a network and they give you /24. So 172.10.21.21/24. Now first thing you need to know is 172. What is that? That is part of a class B, right? I mean, by default it is class B, 172. So class B we know is /16. Now in this case it is /24. That means the 8 bit, that is excess of 16, has been borrowed. So the 24th bit, this bit, comes in the 3rd octet. If you know the, I mean, if you count /24, the 24th bit comes in the 3rd octet, right? And the place value is 1. That means we need to add 1 to the 3rd octet to keep getting subsequent network ID. What is the first network ID? We know this, 172.10.0.0, like you see here, and the broadcast ID is 0.255. How did I get 0.255? It is nothing but I know the next network ID is going to be 172.10.1.0 because we are adding 1 to the 3rd octet. So I know 172.10.1.0. 1 minus that is 172.10.0.255. Similarly, the next network ID is 2.0, so the broadcast ID is 1.255. So that goes on and on until I reach what I am looking for. So I'm looking for 172.10.21.21, which is nothing but I should be looking for the network ID 172.10.21.0. So that's the network ID, 172.10.21.0, and the broadcast ID is 172.10.21.255. Is this number in between these two network IDs and broadcast ID? Absolutely. So this is the answer they are looking for, 172.10.21.0, 172.10.21.255. Fantastic. Let's try another example. Right, this example is a little tricky. The reason I put it here is just to show you that what can happen, right? Again, 10.210.170.255/23. This is a class A IP address. Class A is /8. In this case it's 23. That means they have borrowed 15 ones. We are not bothered about 15 ones. What we are bothered about is /23. The 23rd bit comes in which octet? So if you count, 23rd bit comes in the 3rd octet, and it is the 7th bit of the 3rd octet, which is nothing but has a place value of 2. So how do we do? We start with the first network ID, 10.0.0.0. What is the broadcast ID? Before we find out the broadcast ID, we need to find out what's the next network ID. It is 10.0.2.0 because we need to add 2 to the third octet, 10.0.2.0. So 1 minus 10.0.2.0 is 10.0.1.255. So it goes on 10.0.2.0 to 10.0.3.255, 4.0, 6.0, 8.0. It goes on and on until it reaches 10.0.254.0. The next network ID is when you add 2 to it, it becomes 256. That's not valid. So it is 10.1.0.0. Remember, from 254.0, if you add 2, it will get reset and it becomes 1.0. Exactly like 13 hours 59 minutes 59 seconds plus 1 is 14 hours 0000, right? Similar concept happens here. So again it goes 10.1.2.0, 1.4.0, 1.8, it goes on to 1.254.0. Again, if you add 2 more, it becomes 10.2.0.0 and goes on and on and on until it reaches 10.210.0.0. Now if you look at the question, we are interested in this 10.210. network. So again we'll follow the same thing, 10.210.0.0 plus 2 you're adding, then you keep adding 10.4.0, 10.6.0, 10.8.0. it goes on and on until we reach 10.210.170.0 because that's what we are interested in. 10.210.170.0, 10.210.171.255. This is the network. If you look at this range comes in between these two values. Two things. The reason I give you this example is, one, whenever you see 255 in any IP address, that does not mean it's a broadcast ID. We need to calculate it. So in this case, 10.210.170.255 is not a broadcast ID. Second, we need to check, we need to count the slash, we need to count your subnet mask values to see which octet we are working in. In this case, we were working on the third octet. Of course, the carryovers went to the second octets, but we were working ideally on the third octet. Another way to answer this question is, because we know the changes are happening on the third octet, we could have started at 10.210.0 instead of counting all those numbers. So we would count at 10.210.2.0, 10.210.4.0 and on and on and on until we reach 10.210.170.0. Don't get confused. You could start from 10.0.0.0. I was just trying to show you a shortcut, right? I hope there's no confusion. I hope you understood what I was trying to say, and I hope you understood everything that we learned till now. If you have any doubts, pause this video or maybe just watch this video again, because the concept is very, very simple. Right? Supernetting. This is a beautiful concept. Now, supernetting is a concept that is ideally used in the routing concept, and I know that we haven't yet started routing, but I wanted to talk about supernetting here because supernetting and subnetting are complementary. Now, subnetting is breaking down a large network into smaller networks, and supernetting is exactly the opposite, where you take smaller networks and combine it to one big network. Now, it is like this. Think about USA as one country. Now, subnetting is breaking this large country into small states. Let's assume that the whole world is one chunk of land, right? And let's assume that somebody is traveling from Europe to America. And let's say we have the signboard, like the signboards we have. Let's say we have a signboard in Europe. Every state is listed down there and it says, you want to go, you need to take this road. That's not practical. You will have a massive board. Instead of that, they could just list saying the United States of America, you need to take this way. That's it. So from Europe, you just have one board which says towards United States of America, you need to go this way. Very simple, isn't it? This is what supernetting is all about. It is just, instead of having multiple entries in your routing table can be compared to the signboards that you have on your highways. So instead of having multiple entries on the routing table for different networks, the routing table is summarized so that listings are reduced. if you compare it to the real life example, it is like how we discussed. Instead of having all the states of United States on the board, they could just say to United States, take this road, go this way. Simple, isn't it? Right, let's see how it works in the networking industry. Now, if you remember in our last video, we did subnetting, and we broke down this class C IP address into 4 networks. So 192.168.100.0, 100.64, 100.120, 100.192 were 4 different networks. Now we also know that 192.168.100.0/24, which is nothing but the class C network without subnetting, it included all these IP addresses, right? So it started from here and it ended here. It included all these 255 or 256 IP addresses were included in 192.168.100.0/24. Now we broke it down into 4 networks: 192.168.100.0, 100.64, 100.128, 100.192, all /26. But if we didn't break it, we could represent all these 4 subnets by representing it as /24 and as 192.168.100.0/24. It includes all these 4 subnets, right? That's what Supernetting is. So instead of the router having all these network IDs one by one listed, they could just list one network ID, 192.168.100.0/24, and that includes all these 4. And this is the secret how the internet can work. I mean, internet has so many IP addresses, and if routers start listing all of them, the internet will break. Summarization is what makes the internet run so efficiently. You will see when we talk about routing concepts in one of the future videos, you will understand what I'm trying to say. But for now, just know how Supernetting works. Right, let's say there were 4 networks like this: 172.168, 197.0, 198.0, 99.0, 200.0, 204.0, 206.0/24, all of them. How do we summarize these 6 IP addresses into one IP address? Firstly, we need to check where this changes. So the first 2 octets don't change at all, so we are not bothered about it. The change is happening in the 3rd octet. So let's just convert that into binary. In this, let's see where is the change. Now, the first 4 bits don't change at all. It's only the last 4 bits that change. So the green part does not change at all if you compare these 6. Only the last 12 bits, or rather in this case only the 4 bits are changing, right? So how do we convert this into one network? So what you do is make everything as 0, everything beyond this line as 0. So it will be like this: 172.168 dot this part, which is, if you convert it to decimal, it is 172.168.192.0/20. How did I get /20? Is count how many bits are here. So this has 8 bits, this has 8 bits, and the 4 bits here. So 8, 8, 16 plus 4 is 20. So 20 bits, 172.168.192.0/20 represents all these 6 networks. People who have concentrated would know that /20 means there are 16 networks in between this. So 172.168.192.0, 193.0, 194.0, it goes up till 207.0. So we are only representing 6 networks in that 16. That means there are 10 networks which is already included in this, but which is not existent. So when we summarize, we need to make sure that we summarize in a way that includes all of these networks. Right, let's test what you know. So these are the questions for you. Take your time to solve these problems and send your answers in the comment section below this video. I hope these videos are really helpful. If you don't understand anything, watch the last 2 videos. I mean, this video and the last video again. I hope that is enough for today. Thank you so much for watching. If you have any questions, please feel free to write into me and I will try to answer as soon as possible. Please don't forget to share these videos on your social media. Thank you so much once again.